Our planet is a place of wonder. From the vastness of space, Earth appears as a vibrant blue and green marble, swirling with clouds and teeming with life. But what we see from above is only the beginning of its story. The surface, with its familiar landscapes and ever-changing weather, is just a thin shell compared to the mysteries that lie beneath. For billions of years, Earth has been evolving, shaped by forces both seen and unseen, creating a world that is as dynamic below ground as it is above. We see mountains rising high into the sky, their peaks dusted with snow. Oceans stretch endlessly, their waves crashing against ancient rocks. Forests blanket the land, their canopies alive with the sounds of countless creatures. These landscapes are breathtaking, and they remind us of the beauty and diversity of our planet's surface. Yet for all their grandeur, they are only a small part of Earth's story. The real secrets lie hidden, deep below, where few have ever glimpsed. But what lies beneath our feet? Every step we take is above a world we rarely consider, a world of solid rock, shifting plates, and unimaginable forces. Deep inside Earth is a hidden world, one that is shrouded in darkness and mystery. Here, temperatures soar to thousands of degrees, and pressures are so intense that rocks behave more like slow-flowing liquids than solids. This is a place where the very building blocks of our planet are forged and transformed, far from the light of day. This is the Earth's mantle, a vast layer of hot, dense rock that lies between the crust and the core. The mantle makes up most of our planet's volume, yet it remains largely inaccessible and mysterious. Scientists have spent decades trying to understand its secrets, using everything from seismic waves to laboratory experiments that recreate its extreme conditions. The mantle is in constant motion, slowly churning and flowing, driving the movement of continents and the eruption of volcanoes. It is the engine that powers our dynamic planet. We can't journey there ourselves. The mantle is simply too deep, too hot, and too dangerous for any human to visit. But that hasn't stopped us from trying to unlock its mysteries. Scientists have developed ingenious ways to study this hidden realm. By examining rocks brought to the surface by volcanic eruptions, and by analyzing seismic waves that travel through the Earth, they have pieced together a picture of what lies below. Each discovery brings us closer to understanding the forces that shape our world. One of the most important clues comes in the form of a rare rock called Dunite. This greenish, coarse-grained rock is made mostly of the mineral olivine, and it forms deep within the mantle. Occasionally, powerful geological forces push Dunite up to the surface, giving us a precious glimpse into the world beneath our feet. By studying Dunite, scientists can learn about the composition, temperature, and history of the mantle itself. Dunite is a rare and special rock. Its unique texture and mineral content set it apart from the rocks we find on the surface. Each sample of Dunite is like a time capsule, preserving information about the conditions deep within the Earth at the time it formed. In museums and laboratories, geologists carefully examine Dunite's crystalline structure, searching for clues about the processes that shape our planet from the inside out. Dunite tells a story of fire and pressure, a story written over millions of years. It forms in the intense heat of the mantle, where minerals are squeezed and transformed by unimaginable forces. Sometimes Dunite is carried to the surface by volcanic eruptions, emerging in a blaze of molten rock and ash. Other times it is exposed by the slow movement of tectonic plates, revealing its secrets only after eons have passed. Each piece of Dunite is a testament to the power and complexity of our planet's inner workings. The story of Dunite helps us understand not just the past, but also the future of our planet. By studying these ancient rocks, we gain insight into the forces that have shaped Earth for billions of years, and that will continue to shape it for billions more. The hidden depths of our world are a reminder that there is always more to discover, and that the greatest mysteries often lie just beneath the surface. Dunite is named after Dun Mountain in New Zealand. It's here that this unusual rock was first discovered. What makes Dunite so special? It's mostly made of a single mineral, olivine. Olivine is a beautiful green mineral. It gives Dunite its distinctive color. The olivine in Dunite comes from deep within the Earth's mantle. When we hold a piece of dunite, we're holding a piece of Earth's interior. Dunite forms under extreme conditions. Deep within the Earth's mantle, temperatures are incredibly high. Rock melts into a liquid called magma. This magma doesn't stay still. It rises towards the Earth's surface. As the magma rises, it cools slowly. This allows crystals of olivine to form. Over time, these crystals accumulate and solidify. This is how dunite is born. Dunite is a rare and fascinating rock, found only in select locations scattered across the globe. Unlike more common rocks, dunite's presence is a clue to extraordinary geological processes that have shaped our planet over millions of years. Its distribution is not random. Instead, it marks places where the Earth's deep interior has been exposed at the surface, offering scientists a window into the planet's hidden layers. These locations are often closely linked to tectonic activity, where the immense forces of shifting plates push, pull, and sometimes tear the Earth's crust apart. At these boundaries, rocks from deep within the mantle can be thrust upwards, creating dramatic mountain ranges and exposing ancient materials that are usually hidden far beneath our feet. One of the most famous places where dunite is found is Oman, on the southeastern edge of the Arabian Peninsula. Here, the landscape is dominated by rugged mountains and vast deserts, but hidden within these arid expanses are outcrops of dunite that tell a remarkable story. In Oman, a massive section of the Earth's mantle was pushed up and exposed at the surface during a dramatic event millions of years ago. This process, known as abduction, is rare and allows us to study rocks that would otherwise remain buried deep within the planet. The dunite here is a direct sample of the mantle, providing invaluable information about the composition and evolution of the Earth's interior. By examining these rocks, geologists can unlock secrets about the processes that formed our planet, the movement of tectonic plates, and even the origins of valuable minerals. Each sample of dunite is like a time capsule, preserving evidence of ancient geological events. Dunite is also found in other remarkable locations, such as the Appalachian Mountains of North America and the mountains of Cyprus. In these regions, the story is similar. Tectonic forces have brought deep mantle rocks to the surface, creating unique geological landscapes that attract scientists and adventurers alike. Along the Pacific Ring of Fire, a region famous for its intense volcanic activity and frequent earthquakes, dunite can also be found. Here, the constant movement of tectonic plates creates a dynamic environment where mantle rocks are sometimes forced to the surface, adding to the region's dramatic scenery and geological diversity. Each of these locations, whether in the deserts of Oman, the mountains of Cyprus, the ancient Appalachians, or the volatile Pacific Rim, tells a unique story about the Earth's dynamic history. The presence of dunite is a testament to the powerful forces that continue to shape our world, reminding us that the planet's surface is just the beginning of a much deeper and more complex story. Dunite is a rock that truly engages the senses, offering a unique experience for anyone who encounters it in the field or in a collection. When you first pick up a piece of dunite, you'll notice its weight and density. This is a rock that feels substantial in your hand, a testament to its mineral composition. The surface is often rough and gritty, a tactile reminder of its coarse-grained nature. One of the most striking features of dunite is its texture. If you look closely, you'll see that it's made up almost entirely of olivine crystals, which are large enough to be seen without any magnification. These crystals often have a glassy luster and can sometimes even sparkle in the sunlight, giving the rock a subtle, almost hidden brilliance. Running your fingers over the surface, you can feel the individual grains, each one a tiny piece of Earth's deep interior. The color of dunite is another aspect that makes it fascinating. While many rocks have a fairly uniform appearance, dunite can display a surprising range of hues. Some samples are a soft, pale yellow-green, while others are a much deeper, richer forest green. This variation is due to differences in the composition and the presence of trace minerals, as well as the conditions under which the rock formed. When you compare different pieces side by side, the spectrum of greens becomes even more apparent. Some Dunite rocks almost glow with a light, almost neon green, while others are so dark they're nearly black. The interplay of color and texture makes each specimen unique, and geologists often use these visual clues to learn more about the rock's history and the environment it came from. Over time, Dunite doesn't stay the same. Exposure to wind, rain, and temperature changes causes the rock to weather, gradually altering both its color and its texture. Fresh Dunite might be bright and vibrant, but as it weathers, it can take on more muted tones, sometimes even developing a rusty or brownish tint as iron within the olivine oxidizes. The surface can become even rougher, and cracks may appear, telling the story of the rock's journey through time. Weathering doesn't just change the appearance of Dunite, it can also lead to the formation of entirely new minerals. As water and air interact with the rock, secondary minerals like serpentine or magnetite can begin to form, sometimes creating beautiful patterns or veins within the Dunite. These changes are a reminder that rocks are not static, they're constantly evolving, shaped by the forces of nature over millions of years. So when you hold a piece of Dunite, you're not just holding a rock, you're holding a record of Earth's dynamic processes, captured in color, texture, and form. Dunite might seem like a simple rock, but it plays an important role in our lives. It's used in the steel-making industry. The olivine in Dunite helps to remove impurities from molten iron. This makes the steel stronger and more durable. Dunite also holds promise for environmental solutions. It has the ability to absorb carbon dioxide from the atmosphere. This makes it a potential tool in the fight against climate change. Dunite is more than just a rock, it's a key to understanding our planet. Geologists study Dunite to learn about the Earth's mantle. They can analyze the minerals in Dunite to determine its age and origin. By studying Dunite, we can learn about the processes that shaped our planet. We can gain insights into the formation of continents, oceans, and even life itself. As we face the challenges of a changing climate, Dunite offers a glimmer of hope. Its ability to capture carbon dioxide could be harnessed to reduce greenhouse gas emissions. Scientists are exploring ways to use Dunite for carbon sequestration. This could involve grinding Dunite into a fine powder and spreading it over land or in the ocean. While more research is needed, Dunite's potential as a natural climate solution is exciting. Dunite, a rock from Earth's depths. It tells a story of our planet's ancient past, a story of fire, pressure, and the constant movement of the Earth's crust. But Dunite is not just a relic of the past, it has the potential to shape our future. As we continue to explore and understand Dunite, we gain a deeper appreciation for the wonders of our planet, and perhaps we can unlock solutions to the challenges that lie ahead.